All right, Mr. Rainsberg here. We are going over some of the problems that relate to the team challenge for Chapter 5. And the first one deals with kind of exponential. And the one of the team challenge is going to be a modeling problem, one that's a story problem. But I kind of look at all the different characteristics over here on the side. And you're going to be given information. In this case, you're given 2 points. You're given 0.18 and 4.72. And you're going to be asked to write an equation. Probably going to be asked to plug in a value, plug in an input, find the output. And you might even be asked to find what an input is based off of an output. And that's really what these 3 things are looking at. Now, this is just a straightforward problem. It's not a modeling, but the modeling one deals with the same concept. So in this case, we're going to go piece by piece. We're going to first write the exponential function that this represents. So what do I know here? I know that I have, I think I like a table, I have a 0 term of 18. That's my initial. But then after 4 units, whatever we want to call it, based off what the story problem is going to be, it goes up to 72. And now I need to write an equation for exponential. That's y equals a times b to the x. And the problem is I don't know too much, you would think. I do know my 0 term. I can see that my 18 is my a value. That's good news. But I don't know my base. But the good news too is I do know an x and I do know a y. So I know 3 out of the 4 variables, which means I can solve the equation. So I'm going to plug them in. I get 72 equals 18 times some base, we don't know, to the 4th power. Alright, so I'm going to take and I'm going to isolate the variable. So I'm going to divide both sides by 18. I know that if I take 18 times 4, it's 72. So good news is that's 4. Perfectly. Well, I'm going to do the 4th root of 4. Now, be careful. The answer is not 1 for your base. You're going to have to go to your calculator. Remember, it's under math. And if I look at option 5, it's x to the root. So I could type in 4th root of 4. It is 1.414. So I'm going to go ahead and say it's approximately, we'll do 1.41. That's your base. Now, that's not the equation. The problem asks us to first write exponential equations. So I know y equals 18 parentheses 1.41 to the x power. That takes care of the first part. So find your 0 term, your initial value, and that's going to be your a. It's kind of like your y-intercept in this case. And we're going to plug in the other information and solve. Now part B says, you know what? What's the y value after 10 units, 10 hours, 10 minutes, 10 weeks, whatever it is in context of the problem? Well, that's as simple as you have an input. So 1.41 to the 10th power. So again, we're just going to go to the calculator. I'm going to type in 18 parentheses 1.41, 1.41. And I'm going to raise that to the 10th power. There's no harm in having that 0 there. It's going to still calculate it for me, so we can go through, and I get 559.066, so y is approximately 559.07 units, whatever we're dealing with. And so that's the second one. So I found the equation, I was given an input, and I plugged it in. What about when you're given an output? You know, when y is 250, so 250 equals 18 times 1.41 to the x power. Well, I'm going to think mathematically first. I need to isolate the object that contains my variable. My variable is in the exponent for the 1.41. So then I'm going to take my 250 and I'm going to divide it by 18. And I hit that. Oh no, it's a decimal. Don't do it. Don't write down the decimal. We're going to go to math, fraction, and I get 125 ninths. So I have 125 ninths equals 1.41 to the x power. Awesome. But there's still a problem. My variable is located in the exponent. So we need to figure out how do we solve. Well, 2 ways. If your variable is in the exponent, you can find common bases, which is covered on the non-calculator test. Or you can use logarithms. And in this case, I don't know a common base between 125 ninths and the 4th root of 4. So I'm going to use log. I'm going to take the log of the left side and I'm going to take the log of the right side. So I'm just going to go ahead and duplicate this down here. So I'm going to have log of 125/9 equals the log of 1.41 to the x power. Now the reason why that's helpful is not because of the left side. The left side is going to stay as is. The reason why that's helpful is because I can take on this right side that x using my power property with logs. This exponent can come down and go in front of my log of 1.41. Now to solve for x, I'm just going to divide. I'll keep it on the same side so you can kind of understand what I'm doing. I'm going to take my 125/9 inside the log, so log of 125/9, and I'm going to divide by my log of 1.41. And that's going to equal my x. Now don't worry, you may think this is a little bit different than the, hey, what power blank gives me blank, but it's the same. So I'm going to type in, ooh, it looks like a fraction, so I'm going to go alpha y equals, I'm going to have a fraction. I'm dealing with just plain old log, so log of 125/9. And then on the bottom, I have log of the 4th root of 4, which we just approximate as 1.41. And I get 7.66. So I have, it is approximately 7.66. Now you may wonder what's going here then, Mr. Ainsberg. What goes in that spot? And that's the part where we can come up here. Some of you are really good with asking yourself that question. Hey, what power blank gives me blank? What power 1.41 gives me 125/9? Well, let's take a look at that. If I go to math and go to log base and go 1.41 and I do 125 divided by 9, notice those are the same answers. So one of them was a concept where we learned multiple ways of solving. A lot of you wanted to stick with the question, but if you don't memorize that question, memorize that concept, understand that concept, it's a little bit harder to do this one. But if you log both sides, it's a very step-by-step approach. All right, so there was the first one. That covered all three things. Let's again reiterate. You're dealing with a modeling problem, so you're going to be given information in a story that you have to figure out, but you're going to be given 2 points that you can use. Very similar. You have an input value. You're asked to find the output, or I give you the output, and you're going to have to use logarithms to find the input. All right, next one. Oh, the dreaded sign chart. Well, for the team challenge, we said it's going to be a polynomial. In this case, it's a quadratic. And for the individual, it's a rational. So let's take a look. Can't solve this yet because it's not set equal to 0. So I'm going to do 2x squared minus 3x minus 20 less than or equal to 0. Much better. Again, factoring. I guess I'll just do it up here. I have a 2x squared. I have a negative 20. So I want numbers that multiply to negative 40x squared and add a negative 3x. I'm thinking that's negative 8x and 5x, and I know I'm right. So the top row has a 2x in common. I can factor it out with the GCF, which makes this 2x times x is x squared, 2x times negative 4 is negative 8x, negative 4 times 5 is negative 20, and x times 5 is 5x, so that works. Great. I have 2x plus 5 times x minus 4. Now, at this point, there's nothing too different than just factoring and solving. I mean, if I were to solve this, you'd go, hey, x equals negative 5 halves, x equals 4. And you would be done if it was an equation. But it's not an equation. It's a sign chart. You're still, doing, like, technically, this is the hardest part, is the factoring. The sign chart's a pattern. So let me kind of make my number line. On that number line, I know I'm going to have my solutions of negative 5 halves, and I'm going to have my solution of 4. First question, open or closed circle. And for that, we have to look at this. Because it's or equal to, that means I can have negative 5 halves as an answer. I can have positive 4 as an answer. So those are closed circles. If it was just less than, it would be open. Now what? Well, the idea is we have to plug in numbers to the left of -5/2, between -5/2 and 4, and to the right of 4. So what I'm going to do is I'm just going to pick some test numbers. I'll write them in purple just so we can kind of tell what they are. If you can memorize them, you don't need to write them down. So I need a number to the left of -5/2, -2.5. I'll just use -5. Between -5/2 and 4, man, 0 is a nice and easy number to plug in. Greater than 4, I could plug in 10. I'm just going to use 5 because 5 is greater than 4. Now, technically, what I'm doing is I'm plugging them into my equation, which the easiest one to plug into is this one, the factored form. It's technically easier mental math to plug into factor form than it is to square and do all the other stuff. So that's why off to the side you see us write down our factors. Again, I'll just shrink this over. And we have a 2x plus 5. And we have an x minus 4. Really, it's just my placeholders. I'm keeping tabs of what I'm plugging in and what I'm getting number-wise. So if I plug in -5, so instead of x, this can be -5. So if I have 2 times -5, so 2 times -5 is -10, plus 5 is going to be -5. I'm going to get a negative number. If I do -5 minus 4, if I plug in -5 here for x, -5 minus 4 is a negative number. Notice you are multiplying those together. So what's a negative times a negative? And the answer there is it's a positive. So I know their product would result in a positive number. If I plug in 0, 0 plus 5 is a positive. 2 times 0 plus 5, positive. 0 minus 4, negative. So in that case, I get a negative number based off their product. Now if I plug in positive 5, 2 times 5 is 10, plus 5 is 15. I know it's a positive number. And then 5 minus 4 is 1, which is positive. And a positive times a positive, that's positive. Now, how does that help? I have positives, negatives, positives. Well, what do I know? Well, I'm looking for one of those. I'm either looking for the set of positive numbers or I'm looking for the set of negative numbers. And so I have to come back to my inequality and I have to look at this. This says I want this expression to be less than 0. I want it to be smaller than 0. So that means I want it to be a negative number. Well, my negative numbers exist between -5/2 and 4. So that's my answer. My lowest number is -5/2. My greatest number is 4 parentheses or brackets, though. They're both closed circles. So they're both brackets. That's a sign chart. All you're doing is plugging in numbers and looking at what their signs are. Well, how did you get the -5, 0, and 5? Why didn't you use -10, 1, and 8? I could have. I just find my mental math a lot easier with -5, 0, and 5. As long as they're in between the numbers, it works. And that is just really the main idea behind a sign chart. The next problem is, oh man, inverses. So you're given a logarithmic function, log base 3 of x plus 5, and you're asked to state the domain of it, domain and range of it, and then you're being asked to find the inverse. So let's kind of go through this. If I'm looking at this one, and I'm thinking through domain. Now one, I have a calculator down here. Isn't that a nice feature? But do remember what kind of happens. You know what? Let's actually look at the calculator. I think that's important. So I'm going to go to y equals. Let's clear this out. Let's go to math log base. And let's do 3 of x plus 5. And I'm going to hit zoom standard, zoom 6, just to make sure I'm set. There it is. Now, do you see why I wanted to look at the graph first? Is if you look at the graph, look at this. It's going, it's going, it's going, it's going, it's going, it's going, it stops. What did we learn before? Well, we learned that there are going to be vertical asymptotes for logarithmic functions. So I know, and I'm going to write this right here, I have a log, if I'm looking at transformation form, x minus h plus k. So that you are aware, this right here, your h value is your vertical asymptote, x equals h. And if I were to look at that graph, you would see there that it is really close to -5. You can see it's going, and it stops. It's not quite there. So what does that mean? Well, if that means if I'm graphing, that's right, I'm going to graph without a grid. It's possible, people. And I can do this, boom, 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 and I'm going to do -1, -2, -3, -4, -5. So here's -5, and I'm just going to do dash, 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 dash. I need to graph the asymptotes for my logarithmic functions before I look at the calculator, before I physically start graphing over here, because the calculator is going to stop it. And you need to always finish it. So then I can go to my calculator, figure out the rest. Remember, go to the table, plug points. I'm just going to do this, and I'm just going to get an approximation. Not even close, but good enough. Now, why did I do that? Well, I can see that my x values, they stop at -5. They don't go past -5. By the way, they don't even equal -5 because that's a vertical asymptote. So I know for this, my domain, the lowest it goes is -5, and it can go all the way to infinity. Parentheses or brackets? Well, you can't touch infinity, so that's a parentheses. What about the -5? It's a vertical asymptote. So that means it's not included. So there's my vertical asymptote, so I have to use parentheses. Now range, I mean this, we had to finish it. It does go down forever, which is why it's really important you understand to graph that vertical asymptote first, because you may be tempted to go, ooh, there's a range right here, it stops, but it doesn't. Calculators are flawed. You have to fix their flaws. And so we have here, my range is every real number, -infinity to infinity. So there it is. There's state, the domain, a range. By the way, I could ask you to graph it as well, and you can do a better graph than the one I have. Find the inverse. So, ooh, inverse. Let's do that one over here. Well, what's the first step for finding an inverse? Switch the x and the y. So I'm going to have x equals log base 3 of y plus 5. All right. First step would be to isolate the log, the whole log object. Not the word log, but the object that's with the log. So it is isolated. So what's the next step? The next step is to convert, well, it's inverse. What's the inverse of a logarithm? The inverse of a log is exponential form. So then I'm going to take my base, this is my base of 3, and I'm going to connect it to the exponent. I'm going to bump it over, because remember, a log equals a power. So x is my power, and this should equal y plus 5. Well, if I want to do the inverse, I'm going to subtract the 5, and I'm going to write it. It's a function. I'm going to write it in function notation. The inverse is 3 to the x minus 5. Now, at this point, even right up here, I showed bumping it. I outlined which parts are base, which parts are power. You could go with the question, hey, what power of 3 gives you y plus 5? And that's what this says. What power 3 gives me y plus 5? Well, the power is x, so 3 to the x equals y plus 5. And then go through there and solve. Not done yet. It asks for the domain, and it asks for the range. So you know what? Let's at least look at the graph and see what happens. So I'm going to clear this out, and I'm going to do 3 to the x power, and I'm going to have minus 5. And I'm going to hit graph. Now what do we notice here? If I look at that graph, I can see that this has a horizontal asymptote. And it's really interesting because that horizontal asymptote, it looks like it's at -5. So I mean, if I look at this graph, and we'll kind of do the same thing as a graph without even, really doing it. It goes like boom, 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 1, 2, 3, 4. Here's -5. It looks like there is a horizontal asymptote there, and it goes like this, and goes up. Well, that's nice. By the way, isn't that nice? It goes to the right forever. It goes to the left forever. So isn't that mean -infinity to infinity? That's interesting. We've seen that before. What about the range? Well, there's an asymptote there. The asymptote's at -5, and it's an asymptote. It can't touch it, so it's -5 to infinity. Now, hold on a second. The logarithmic function had a vertical asymptote at -5. Our exponential function had a horizontal asymptote at -5. Horizontals and verticals are inverses of each other. It makes sense. Vertical asymptote, x equals -5. Horizontal asymptote, y equals -5. Don't we switch the x's and y's? What else can I see here? What else switches? They reflect over the line y equals x, but what else switches? Look at the domain of the original. Look at the range of the inverse. Do you see what else switches? Isn't domain the x values and range the y values? And don't we switch the x and the y? So shouldn't the domain and range switch as well? These are the patterns to look for when you're writing down answers. Not just to do the answers, but to kind of watch what you're writing. All right, so next up, identify the important parts for f of x, and this is 1 over f of x, so this one kind of deals with the idea of reciprocal. A function and its reciprocal. So here's my original function now. I was very vague in this set of directions. Identify all the important parts. Well, I'm going to set this equal to 0 and factor. I get x minus 6, x plus 2. What do I know? I know I have solutions at 6 and negative 2. I'll write that plus 2 a little bit better. Now, how is that helpful? There's a lot here. I'm just going to talk about important parts. So let's kind of look at this. I will not draw a scale. Here is 2, 1, 2, 3, 4, 5, 6. Did that backwards. So I'm going to do this. It is 6 and negative 2. So 1, 2. So here's negative 2, 1, 2, 3, 4, 5, 6. And those are my x-intercepts. Boom, 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 boom. Now, why is that helpful? What other important parts are there to a quadratic? A vertex. A vertex is an important part of quadratic. Well, where is the vertex located? I can memorize the axis of symmetry formula, x equals negative b over 2a, or I can realize if I have the solutions, it is going to be the midpoint. So what number is halfway between negative 2 and 6? And so if I think about it, the halfway number is going to be 2. Add them together, I get 4. Divide by 2, you get 2. Well, how do I figure out the y value of the vertex? Well, that x is an input. 2 minus 6 is negative 4. 2 plus 2 is positive 4. So negative 4 times 4 is negative 16. Good news, as I said, it's not going to be all the way to scale. So there's negative 16. That's amazing. So at 2, negative 16, there is my vertex. Boom, 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 boom. Here is my quadratic. Isn't that wonderful? Not drawn to scale. Any other important parts? I could say y-intercept. It has a y-intercept of 0, negative 12. Anything else I could think of? Probably not for this one. Probably not for a quadratic. Those are the main things. I could deal with domain and range. Domain's negative infinity to infinity. Range is y is greater than or equal to negative 16, or bracket negative 16, comma, infinity. But what about its reciprocal? Well, let me write down what we have. And I'll shrink this down. I'm going to increase that graph again because we're going to need it. But if I look at the reciprocal, 1 over f of x, I'm going to do it in factored form. 1 over x minus 6, x plus 2. So hold on. That's a rational function now. I mean, I cannot, look at this. This x equals 6 and x equals negative 2. I mean, those are my solutions before, right? But now they're located in the denominator. Can't have that. You cannot divide by 0, so x can't equal 6. X can't equal negative 2. Those are my vertical asymptotes. I have vertical asymptotes at x equals 6 and at x equals negative 2. That's a good thing. Do I have any other asymptotes? And I could use the calculator if I wanted to, but I could look at the degree. If I have what the original was, 1 over x squared, whatever the rest was, the degree in the bottom is bigger than the degree in the top, which means I have a horizontal asymptote at y equals 0. So I have a vertical asymptote, I have a horizontal asymptote. Again, I can look at the graph in the calculator. But what if I wanted to graph it? Well, if I wanted to graph it, I'm going to grab this one, I'll duplicate it, and I'll make it a little bit bigger, not much bigger. Here we go. Well, we know we have a vertical asymptote here. We have a vertical asymptote here. What about the rest? Oh, and you're right, Mr. Ranger forgot to graph the horizontal. That's important too. What about the rest of it? Well, the rest of it goes along these lines. When you do a reciprocal, you are doing 1 over. It's kind of, think of like the flipping it. But I'm not going to flip it, just flip it over the x-axis. I have to flip it when it comes to the graph itself. So if I look at this, this is a big number here. I mean, it's negative 16. What is that flipped? Well, negative 16 over 1 becomes 1 over negative 16. I mean, it's going to be a really small number. You know, this right here is a really small number. What if I flip that? It's going to be a really big number. And the same thing here. So it's kind of like you're flipping it, but not flipping it with the x-axis, with the horizontal as the boundary. And then this one comes along this side, and this one comes along this side. So if it was big in the beginning, the reciprocal is going to be small. If it's small in the beginning, the reciprocal is going to be big. Think of it like opposites in a way. But the main thing I wanted to get from here, let's make sure, did I explain the relationship? 1 over, I explained the relationships of the graphs, that I wrote it, but I didn't explain it. The solutions to the function are the vertical asymptotes to the reciprocal, because now it's 1 over that. All right, so there is the end of the team challenge problems. It was 4 problems. I wanted to talk through them a little bit more in case you were having some trouble with them. Hopefully this helps, and good luck on the team challenge.